Hello. Today we're going to be doing factoring by grouping, which is a new method of factoring for us. So factoring by grouping is going to happen when you have 4 terms or 6 terms. It's going to be an even number of terms. Now for us, we're going to focus on when there's only 4 terms. So doing the split middle term method is not going to work because you have too many terms there. So the very first goal is to identify if you have a GCF. That's the first question you have to ask yourself. Is there a GCF? After you take out any GCF, then what we're going to do is we're going to split the groups in two and factor by taking out a GCF out of each of those groups. Okay, so looking at this one, notice that A is set up here. There are 4 terms. There are no GCFs. So what we're going to do is we're going to split this in half. And at this point, it should look familiar because this is how we do split middle term. We actually already use factoring by grouping. So what do the first 2 terms have in common? They have an x. So we're going to divide an x out of each of those. So we are left with x minus a when we do that. The next 2 terms have a c in common, so we're going to factor out a positive c. When we divide by c, we get x minus a. Now, as before, these groups have to be the same. So the x minus a is going to be one of our factors because we're going to factor out the x minus a, and the other factor would be x plus c. If your groups aren't the same, that means something went wrong or it's not factorable, one of the two. You can always check your answer by distributing. So you get x squared plus cx minus ax minus ac. And while it's in a different order, it is still the exact same thing we started with. So this is the correct answer. So let's try this next one here. We chop it in half. We say, hey, those first 2 have an x squared. So we're going to take out the x squared and we'll be left with 2x plus 5. The next 2 have a 2 in common. So we're going to factor out a 2. We'd be left with 2x plus 5. Our groups match, and so therefore 2x plus 5 is one of our factors, and x squared plus 2 is another one of our factors. So for C, there's no GCF, so we can look at this and we can split it down the middle. The first 2 have an x squared, that's your GCF. So we're left with x minus 6. The next 2 don't have anything in common, so we're going to factor out a 1. When we divide by 1, we're left with x minus 6, which is good news because x minus 6 is one of our factors then, and x squared plus 1 would be the other one. Again, you can always check these answers. If you distribute, you should end up with what you started with. The next one, before I split it, when I ask myself, does this have a GCF? This is the first one where you do actually have a GCF. All 4 of these terms have something in common. They are all even numbers. So we're going to go ahead and we're going to divide our GCF of 2 out of our original polynomial. So we get x to the 4th plus 4x cubed minus 5x minus 20. Then what I'm going to do is I'm just going to draw an arrow down and make sure that GCF comes down to my final answer. But now when I'm factoring the rest of this part, I'm just going to kind of disregard it for right now. So I'm going to chop this in half. The first 2 terms have x cubed in common. So if I divide by x cubed, I'd be left with x plus 4. The next 2 terms have a 5 in common, but because it starts as a negative, I'm actually going to divide each of those by a negative 5. So it becomes x plus 4. Now that our parentheses match up as x plus 4, our other one would be x cubed minus 5. And then we still have this 2 that we are bringing down because it was our GCF initially. So all of that together would be our final answer. So we're going to do the same idea here with these next 2. So we're going to chop these in half and we're going to factor out the GCF out of each part. So we get x squared and x plus 1, and then a negative 1, and that becomes x plus 1. And so now what's happening is we get x plus 1 and x squared minus 1. But before I circle my answer, I ask myself, is there anything else that keeps on going? So looking at this, x plus 1 does not factor further. So you're just going to write that as x plus 1. But x squared minus 1, this actually continues to factor. So you can either use your square root property, the difference of two squares, or what you can do is you can say what multiplies to get -1 but adds to get 0. And when you get +1 and -1, you can write your answers as x plus 1 and x minus 1. All three of those then together would be our final answer for this one. So let's try one more. We're going to chop it in half. We're going to factor out the x squared. We get 2x minus 1. We're going to take out a GCF of -4 for the next one. And we would get 2x minus 1. So 2x minus 1 is one factor, and x squared minus 4 is the other factor. Now, 2x minus 1 by itself doesn't factor anymore. There's no GCF or anything else we can do, but x squared minus 4 does continue to factor. So we're looking for what multiplies to get -4 and adds to get 0. So as you think through your number pairs, 2 and -2 works. So you can either do split middle term or you can use the shortcut because our a value is 1. So we can write this as x plus 2 and x minus 2. And if you would have used the difference of two squares, you would have gotten the exact same thing. So this is how you factor by grouping. Thank you very much for listening, and let me know if you have any questions.